The lesson outcome for this video is, I can solve a linear inequality by graphing. Now we've been graphing linear equations for quite some time now in this class, but we are not going to talk about equations anymore that have an equal sign. We're going to talk about inequalities, which means not equal. You guys are probably familiar with our symbols greater than or equal to, less than, and less than or equal to. All right? Just real quickly, with the greater than, we know that 5 is greater than 3, all right, or even 5 is greater than or equal to 3. That would be true with that symbol. Again, the symbol for greater than, a lot of people will talk about it as, you probably have heard it being compared to like an alligator mouth, and the alligator is very hungry, right? So it always eats the larger amount. So this mouth is eating the 5 because it's more than the 3. So 5 is greater than or equal to 3, or just 5 is greater than 3. Those will be true for that. Less than or equal to, same idea here. If we have 0 is less than or equal to 4, yes, 0 is less than 4. Remember, we could also read it this direction, so 4 is greater than or equal to 0. The mouth is again eating the larger amount. We could look at that kind of backwards as well. The thing you have to be careful of, by the way, with these symbols is the negatives. Okay, so for example, is -2 less than -5? Is this true or false right here? Well, that's false. Okay, because -2 is not less than -5, because -5 is more negative, so it's smaller, which means that this is a false statement. So be careful with your integers, your negatives here, when you're looking at your inequalities. All right, so this is a couple of examples of graphs of linear inequalities. Now, we have learned to graph lines. If you just take a second and ignore this symbol right here and pretend it's just an equal sign, I want you to notice right away that we've already learned how to graph this if this was an equal sign. Okay, just again, imagine it's an equal sign. We graphed it by finding the y-intercept b and plotting that right here, for example, right there. And then using our slope of -2, which is -2/1. So from here we go down 2 and write 1, and then down 2 and write 1. So this then would be the line for y equals -2x plus 2. But since this says y is less than or y is less than -2x plus 2, our solution is not simply the values or the points that lie on that line, but in fact, the solution is a little different. The solution is this. The solution to this inequality, for this inequality right here, is any and all points, x and y, that fall within the shaded region. So if you think about that, that means every single point that lies in this shaded region, and far beyond that, because remember, our coordinate planes go on infinitely in all directions. So every point that's, if you can think about it as down and left of this line, all of these points anywhere in the space are solutions to this inequality. Any and all points in that region. So this point right here, would that be a solution to this inequality? Yes, it would. Would this point up here? Yes, it would. Would this point right here? Yep. How about over here? Yes. Points over here again, all around here would also be, though we can't see them on that coordinate plane right now. How about this point right here? Is that a solution to this inequality? No, it is not, because it's not in the shaded region. Neither is this point, or this point, or this point, or this point. Now be careful. Here's my next question. How about this point right here? Right there. That is not a solution to this inequality because it's on the line and the line is dashed. If the line is dashed, it means that the line itself is not part of the solution. Let's think about that point that I was on. Let's see, where was it? It was right here, 2, -2. Is 2, -2 a solution to this inequality? Well, if we put those values, I'm going to write that point down, 2, -2. If we put those values in for x and y in this inequality right here, we will find out that it's false. It's not a true statement. Let's try it, okay? I'm going to put the -2 for x. Here, I'm going to write this right here. There's my inequality. I'm going to put this 2 in for x right here. And I'm going to put this -2 right here in for y. And that's a lot of 2's, by the way. And we're going to check and see if this is a true or false statement. So we have -2 is less than, we're going to do our math, our order of operations. So -2 times 2 is -4 plus 2. And now -4 plus 2 over here is -2. So we get -2 is less than -2. Is that true or false? That's false. -2 is not less than -2. It's equal to, but it's not less than, which means that this point right here is not a solution, which is kind of where I started with all this. This point, since it's right on the purple line, and the line is dashed, it will not be a solution. Now let's compare that to this graph over here. Do you think this point, let's say right here, is a solution? It is. It is a solution because in this inequality situation, this line is solid. When the line itself is solid, it means that the points that are on that line are true for this inequality. So again, let's think about where all the solutions are for this inequality. Well, anything on this line, as well as any point in the shaded region, and again, beyond. All those points are solutions. No points in this area over here, because it's unshaded, will make this inequality true. Again, let's look at the fact that we already know how to graph this. This is in point-slope form. I'm sure you recognize that. So our point would be -2. We're taking this value and making it the opposite when we put it in the point, and then -4. So we start on that point, -2, -4. So -2, -4 is that point we were talking about earlier. So that is a point on the line. And then we use our slope 1. So we go from here, we go up 1, right 1, up 1, right 1. And we draw our line. And then you'll notice that it's shaded in a certain direction. Now we're going to talk about how to make sure that our shading is correct on our graphs in our next examples. But again, very important to start off this unit that we understand that a solution of an inequality is any point, and in fact all the points, for in this fashion here, right, a coordinate pair, that fall within the shaded region. Again, potentially on the line, or in this case, not on the line if it's dashed. Okay, so we started talking about this already on the previous screen a little bit, but I want to make sure you understand that we can determine if a certain point is a solution to an inequality by plugging these values into the inequality and checking to see if it's true. This is going to be a very, very important skill, okay, for graphing inequalities. And you'll see that when we get there, because we're going to be using something called test points. In fact, I'm going to actually change this problem, or this value right here. I'm going to change this to 0, 0. If you already wrote it down, change that. So, because that is 0, 0 is a test point we're going to often use, and I'll talk more about that in a minute. All right, so let's check the point 3, -2, and see if it's a solution to this inequality. All right, so we're going to, of course, like we know, we're going to call this our x value and this our y value because they are. And we're going to plug those in. So we're going to put the -2 in for our y right there. And we're going to put 3 in for x because our x value is 3. And now we're going to find out if this is true or false. So -2 on the left-hand side will stay -2 is less than. 3 times 3 is 9 minus 7. And on the right-hand side, we can simplify one step further. So -2 is less than 9 minus 7, which is 2. Now our question is this true or false? Is -2 less than 2? Is the mouth eating the larger amount? Yes, it is. So this is true. So that means, yes, this is a solution to the inequality. Let's try the next one. All right, we're going to put a 0 in for x, and we're going to put a 0 in for y. It's a very common point we're going to use, 0, 0. So we're going to put a 0 in for y right here. 0 minus 2 is greater than or equal to 3 times the x value of 0 plus 4. 0 minus 2 is negative 2, work on your integer work there, is greater than or equal to 3 times 0 plus 4? Well, that's 4. Negative 2 is greater than or equal to 12. Is this true or false? Well, negative 2 is not greater than 12, and negative 2 is not equal to 12. So this is it true or false? This is false. Since it's false, the answer is no, it is not a solution. Okay, so all that information in the previous few slides leads us to the main idea of this lesson. We need to graph this linear inequality. All right, here are some steps we're going to use in general. We need to figure out what form it's in, then figure out the information we need to graph the line. Make sure that you choose solid or dashed for your line, and then we need to test a point and shade our solution. So first of all, what form is this in? Is it standard, point slope, or slope intercept? Well, that is point slope form. Okay, the ones with the parentheses are typically point slope form, and we need to start recognizing all of our different forms. If we have point slope form, remember, we need a point and we need the slope in order to graph it. That's why it's called point slope form. So the point, remember, comes from the x and the y that we need. The x comes from over by x, so if it says minus 4, we're going to write positive 4 right here. And then we've got, by the y over here, minus 2, so we're going to write a positive 2 right here. Our slope, of course, then comes from right here. It's 3, which you can rewrite as 3 over 1 because slope has 2 movements. All right, so now we're going to plot that point 4, 2 right here. And then we are going to rise 3 and run 1. So up 3 and right 1. So up 3 and right 1 will give us a point right here. Now, be very careful at this point that you don't jump to immediately drawing a line. And I know we're used to that, but don't do that because question number 3 is an important one right here. Is this line going to be solid or dashed when we draw the line? Remember what we determined that by is this symbol right here. Okay? That symbol tells us if the points that are on the line are solution to the inequality or not. In this case, since it's just greater than, that means the line will be dotted or dashed. Okay? So we need to draw this line in a dashed or dotted formation. Sorry, it's a little tricky to draw on my iPad here. And there's our line. Now remember, that tells us that the points that are on this line are not solutions to the inequality. Okay? Now we need to decide where the solutions are. Are the solutions up and to the left of this line? Are they in this region? Or are the solutions in this region here? We're going to test a point and shade accordingly. My favorite point to test is 0, 0. You don't have to choose 0, 0, but that is typically the point I will choose if I can. And I say if I can because if the line goes through 0, 0, you can't choose it. Okay, but it doesn't go through that 0, 0 point, so I'm going to choose 0, 0. So like I showed on the previous screen, we are going to put 0 in for y, and we are going to put 0 in for x, and we're going to find out, is this true or not? So 0 minus 2 is negative 2. Is that greater than 3 times 0 minus 4? Well, 0 minus 4 is negative 4. So now we have is negative 2 greater than negative 12? This one can be kind of tricky for some people because they're both negative. This one seems maybe like it's bigger, but it's not because it's more negative. So it's further away from 0 and the positive. So this is actually smaller. So is negative 2 greater than negative 12? Yes, true. And since it's true, that means this is a solution. Since 0, 0 is a solution, it means that all the points in this region are solutions to the inequality. So we go ahead and shade this direction. Okay? And that is our solution set, which means that every single point in this shaded region, and technically beyond, right, that direction, all of those are solutions to this inequality. They will all make it true. So if I pick this negative 5, 0 point and put it in, it would be true. But if I pick this point, 5, negative 5, and put it in, it would be false because this is not a solution. All right. That is how you graph inequalities.